So on this video, we have a very important theorem. It says that if a function f is 1 to 1, in other words, if it has an inverse function, then f and f inverse have the following properties. 1, f composed f inverse of x equals x for all x in the domain of f inverse. And 2, f inverse composed f of x equals x for all x in domain of f. So what this is actually saying is that if you compose f with f inverse, they cancel and you just get x. See? And if you compose them the other way, f inverse and f, they cancel and you just get x. Because, of course, f and f inverse are inverses of each other, right? Because the inverse of the inverse is the original. Okay? So these are super important. They show the relationship. In the future, they'll show the relationship between logarithms and exponential functions, because those are inverse functions of each other. And also trig functions and their pseudo-inverse trig functions. You'll see what I mean by that when we get to the inverse trig functions. They satisfy this property. With trig functions, it gets a little complicated because the inverse is a relation and it's not actually a function, but we do a workaround so that we can still use this. But that workaround makes it complicated, which is one of the main things that throws people with trig functions. So you need to be real familiar and comfortable with these two properties before we get that far. So now's a really good time to work on them and just get really comfortable with them. They're super, super important. In other words, when one composes, I just wrote this out, f and f inverse in either order, the two functions cancel, right? So all cancellation that you've ever seen, if you've done it properly, has all been due to this theorem, due to these two properties, which are really the same property. So here's an example, simple examples. Cube root of x cubed equals x. The cube root function and the cube function are inverses of each other. So here I compose them, the inside function being x cubed and the outside function being the cube root of x. And so when you compose them, you get the cube root of x cubed, and those cancel and you get x. If you compose them in the other direction, take the cube root of x, and take that quantity and cube it. So the inside function is the cube root and the outside function is the cube. They still cancel and you get x. So I compose them both ways, they canceled. That's what the theorem says. And so you can see the theorem in action in these specific examples. So here's another one. X plus 1 minus 1 is x. That's just that, you add a number and subtract the same number, they cancel, right? That's all that is. So this is the add 1 function composed with the subtract 1 function, the inside function being the add 1 and the outside function being the subtract 1 function. So the inside function would be like f of x equals x plus 1. The outside function would be f inverse of x equals x minus 1. Remember, the stuff that you're subtracting 1 from is always going to be x in the original function. In the inverse function in this case. And then if you compose in the other direction, x minus 1, the quantity x minus 1 plus 1, right? So the inside function is the subtract 1 function, x minus 1. And the outside function is the add 1 function, which is x plus 1. And you compose those, you get x minus 1 plus 1, and of course that equals x. So it's just canceling, subtracting, and adding. Canceling by dividing, same thing. If you take first function is 2 times x, so it's the multiply by 2 function. The second function is the divide by 2 function. You compose them and you get x. 2x divided by 2 equals x, because the inverse of the multiply by 2 function is the multiply by a half function or divide by 2 function, right? And if you compose them in the other direction, it looks like this. So the inside function is divide by 2, and the outside function is multiply by 2. So x over 2 and 2x. And when you compose them, remember how to compose. If you don't remember composition, then look back at the section on composition to remind yourself so that this makes sense to you. So those cancel and you just get x. That's very simple.